Good evening. Thanks for joining us tonight for this evening's TI Technology webinar hosted by Texas Instruments, where we will take a look at new computer science resources using TI CX II technology. Becky, if you want to go ahead and share your screen. I see that many of you are joining us tonight for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We also would like to thank everyone for completing the live survey on the right side of your screen. My name is Stacey Thibodeau, and I will be the moderator for this event. I have been in the science classroom now for 23 years. I currently teach at Southside High School in Youngsville, Louisiana, where I teach all levels of chemistry 1 and 2, and I actually have an introduction to robotics class where I get to use a lot of the resources that Becky and Becky are going to share with you guys tonight. I'm happy to introduce our two panelists, Becky Underwood and Becky Beyer. Becky squared tonight. Becky Underwood retired from teaching 4 years ago, where she taught mathematics and computer science in Casper, Wyoming. She has taught everything from foundation mathematics to AP Calculus ABBC, as well as numerous programming courses using many different programming languages, including AP Computer Science. Becky used the TI-82, 83, 84 calculators for the first 20 years of her teaching career. However, in 2011, she was invited to be part of the teacher leader cadre focused on the TI-Nspire. This has changed her teaching as well as working with other teachers for the betters. She has been a T-Cubed regional instructor since 2012. Welcome, Becky.
Thank you. Glad to be here.
And Becky Beyer. Becky is a nationally board certified teacher who teaches 9th through 12th grade. Her current classes at Kelly Walsh High School include AP Statistics, AP Computer Science Principles, AP Computer Science A, C++, and Python. Thanks, Becky.
I'm muted. No, I'm not anymore. Thanks.
I
I'm
was
excited to be here tonight and to share some Python activities with my sound on.
Absolutely. We are expecting a large crowd, so your audio is muted. Please feel free to send questions to all panelists in the Q&A window on the right side of your screen. We will also send general messages in the chat window. This session is being recorded, and as a reminder, we will provide a link to the event's certificate of attendance at the conclusion of the webinar. Once the recording is available, if you would like to follow along with your handheld or software, and we hope you will, we recommend doing this with the recording so you can download the activities and pause and rewind the recording as necessary. I know that I will. We don't expect any issues tonight for audio, but in the event that you do, try selecting Communicate in the WebEx menu, Audio Broadcast, and then click Join. All right, Becky Beyer, want to go over the agenda for us tonight?
All right. Well, we've done the first step. We've done our welcome and introduction. Tonight, we're going to show you the computer science Python resources. We're going to discuss their format and rationale between the different types of activities, because you're going to see some different formats from those depending on the activities you're looking for. We're going to walk through a couple of the activities together, and then don't forget to stay tuned until the end because there is a drawing for a free calculator.
Awesome. Thank you. All right, Becky Underwood, you want to go over the expected outcomes?
Okay, so we are just expecting to help you where you can locate the Python computer science documents on the education.ti website. And the I can statement, I can locate and download an activity to be used to teach my students. I had a college professor once that said, you don't teach Python, you teach students. And so I try to always make sure I put that in there. The next one was I can find activities to use to teach my students Python concepts using the Nspire handheld, the TI Turtle module that you can get and download, the Innovator Hub, and the Rover. And then you understand how the Python computer science documents are set up and put together so that you can use those to teach your students. And you will have, hopefully, by the time we are finished, explored some of these Python activities.
Awesome. All right. Ladies, I'm going to turn it over to you guys.
And there's the chat window again. Okay, when you get to the education.ti.com website, it's kind of like these things, you feel like they're buried, but they're really not. So if you'll notice that you can click on that resources tab, and then when you do so, down at the bottom left, then there is a computer science tab that you will go to. After that, it comes to this page, and up at the top, it says lessons using Python. And that's where all of these Python activities are going to be located. What we're going to do now is just kind of go through what's in each of those activities, the introduction, and just kind of go from there. So Beck, I think it's you next.
Yep. So the very first link that Becky showed said Introduction to Computer Science with the TI-Innovator Rover. When you click on it, there's going to be an option to download 4 different activities. The first 2 Rover activities are going to be just driving basics, sequential programming, speed selection statements that are in there. Then if you click on the next one, once we've got selection or sequential statements and selection down packed, then we're going to go to activity 3 and 4, do some more selection practice, but now we're going to throw in data types and get some input from the users. And then we're going to do some while loops. Then 5 and 6 will reinforce the while loops with some for loops. We'll do some lists, and then some if statements are noticed again in that section. And then last but not least, in activity 7 and 8, we'll have some functions and some library lists. So if you wanted to do selection and loops and sequential functions and lists and libraries, there are going to be built-in activities for you to do with your students that kind of cover that whole gamut of computer science topics. If you, instead of choosing the Rover, you choose the Hub is going to look very similar. You're going to have 5 activities. The first 2 activities are going to assume that you've done, you could have done the Rover, you might not have done the Rover. They're standalone units, so it's going to start back at the very basics, and it's just going to look at what is the Hub and what are the built-in features and how do I use them with Python, and students will do some random integers. Then 3 and 4 will look at loops and selections, and 5 will go back to loops and lists. So again, it doesn't mean you have to do the Rover before you do the Hub. Each one of the bulleted items are going to assume that you haven't done the other one. So when Beck goes to her next slide, it doesn't mean that you have to do the Hub and the Rover before her next main topic. For each main topic, there's subheadings in there that are standalone from the previous ones.
Okay.
All right, so there we go.
All right, so conditional statements is the next one that's listed, and just like what Becky said, for her, the activity she explained, they're broken into 6 different activities. The idea behind this conditional statement is if you are wanting to teach conditionals, if-thens, all of those different things in your class, this item starts at the very beginning, activities 1 and 2, and just uses the handheld. And if all you have are the handheld calculators, maybe that activity and activity 1 and 2 and activity 4 may be all that you would end up doing. But activity 3 has the handheld with the Innovator Hub. Activity 4 is the handheld and the Turtle module, which you can download for free and add to your computer or to your calculator or computer. And then activity 5 is the handheld with the Innovator and the Rover. And then finally, the last one, that has, it's just a collection of activities that are more things that you can use with your students. And we're actually going to look at that at the end after we go through the whole thing. The next set there is functions. And so again, standalone unit, everything that's in there kind of goes as if you've not done the other thing. So like if there's a loop that's needed, there's a little intro that talks about looping when you're in there. But activities 1 and 2, handheld and Turtle only. Again, so if you do not have Innovators or Rovers, you could still use those two activities. Then if you do have the Innovator and Rover, you would go on to activities 3 and 4. And then activity 5 is just like the other one that I was talking about. It's just a collection of other problems, and we'll talk about that a little bit later. So this next set is list, and it's broken into, it says an introduction to list and operating on list. These activities are set up using kind of what they would say is the learn, try, do method, where learn is very highly structured. So it steps you through every single process that the student would need to know. Then it asks you using what you've learned, what you have learned in the learn section. Then it says try. It's not quite as structured, but it makes you apply those previous and go a little bit further without giving you all the steps. And then the do is much more or much less structured, much more independent for the student. It could be used like as a culminating activity or a performance task after you've taught list. Same type of thing happens with loops. It's broken into the 3 different types that Python has there, the do while, the for, and the while loops. And again, the same, learn, try, do, set up exactly the same, highly structured, less structure, and then very little structure where it's here's the task you need to perform, and now go and do that. So they've learned in the others, and now they're actually having to do a performance task. Becky?
So by the time you have gone through the main concepts, so we've done some selection, some iteration, some functions, and some loops, you're going to find 2 end of course projects. The first one, Crack the Code, we're going to look at the end of the webinar tonight. Crack the Code is going to be a guessing game where it creates 5 random numbers and it gives you some hints about what those numbers are. You will see that the code is very scaffolded, yet not very scaffolded, to kind of let students showcase those skills that they've learned throughout the course. And then the Match Me activity hits the same main topics, but notice that one's going to involve the Innovator Hub. So we've got 2 end of course projects, one if you want to do it just on the calculator and one if you want to include the hub. And I think one thing, Underwood, that we might have talked about, but will you flip back to that very first one that had all of them listed? So one thing we talked about a lot when we were developing these activities as a group was what order would be most useful for people. So do functions come before if statements? Do if statements come before selection statements? So hopefully you kind of noticed within each one of those tabs, they build upon themselves. But I think what's great is if Underwood wants to do conditional statements and I want to do loops first, the activities are built so you don't have to do them in order according to topics. And so if you wanted to, you could go through and do an intro in each one of those categories and come back. So they're kind of flexible to let you fit into your coursework the flow that makes the most sense for you in your classroom.
And Becky, I know you're probably going to talk about this more when you get to your end of course project, but can you kind of explain why you did those real quickly? Because I think those end of course.
So the end of course projects were meant to be to encompass everything that's going on there. But if you're someone who's teaching the AP Computer Science Principles course, they're also something that could be done maybe as some practices for those practice create projects that students could use. So those course projects are kind of meant to showcase all of those big main concepts you might need in either an intro to computer science. I teach an intro that's not AP based and I have the AP based. It would fit both of those criteria.
Okay, I'm just going to make sure we didn't leave anything out before I go on to the next. Okay, so what we are actually going to do now, and I've got to get this out of here. Okay, is look at some of these activities. And so I am just going to go through kind of my conditional unit, the way it is set up. So when you open these documents, this is actually for activities 1 and 2. And you might notice it kind of does just kind of a heading here. In this project, you will branch out into the world of conditional statements. So it starts from the very beginning. We have created some programming objectives, but then what I want you to see is we tried to include those computer science principle standards. So they are in here. And so there's some activities if you need to teach to a specific standard, which we all need to do these days, where that's what we're trying to do, and you need to be able to document that, you could see right away that those are listed here. And just like with anything else, there may be some that we left out, but we tried to hit the ones that we definitely were using. As you go on through, notice that this just kind of has an overview at the top that says relational and logical operators. Students will write statements using relational operators and logical operators and will evaluate expressions that use those. So when this first begins, really all you're doing, and I'll just continue through it, it explains what, you get true or false and how you're going to put those together. So it's really everything that I have always taught when I was teaching conditional statements or selection structure. What did I have to do? I had to make sure they understood the relational operators and what those things meant. And then notice there's just some questions. No calculator. You don't need the calculator. We're just checking for understanding. Do they even understand that A greater than B? Is that going to be true or false? That type of thing. I did do a little reminder over here because you don't teach things in the same order, but for students, I went ahead and put that we're going to use the modulus operator in some of these in case that has not been taught yet. Then as you go through, I'm not going to spend a lot of time with this one, but we actually write the program that puts all of that information in here, and they test it to see whether or not their answers were correct. So they don't have to come ask you, did I get this right? Did I get this right? And it walks them through the whole process, reminding them difference in the equals and the equals, that kind of thing. Becky, I'm sorry.
Well, I would say that the page right above, if you're used to maybe coding in Python, but maybe not on your calculator, notice at the very beginning, there's on step number 2, it tells the students, here's how to create a program and how to get it started. So it's actually going to document from the beginning of the program, from turning it on and starting a new program, all the way through.
Correct. Thank you.
Yep.
And then it continues on because we did relational. Now we have to add the and, ors, and nots into this. So those logical operators, and just the same process. You started out, is it true or false? Check your answers. And then what are if statements? Because that's what we're doing. And what are the different types that we have? It walks you through where they're located in the calculator, all of that information. And then down in here, what are the types that we have in Python? So the if else, and the if else. All right. And again, some questions. How would you write a statement, like write an if statement that would do the following tasks? So they just have some practice instead of just going straight to the computer and getting going. So it starts at the very beginning, moves them through modulus operators, writing different things, and you will have all these. Okay. And then we do a walkthrough after that. And I mean, anything that might be extra that's in here, we tried to include a tech tip that would correspond to it. And you might notice over here to the side, we say, put your code here, because we're not going to walk them. If you've used, which I love, the 10 minutes of code activities, which are great to use. I use those more with my math classes, and they gave you every single step that you were supposed to perform. Because we were thinking more computer science, we don't want to say, type this, do this. Once we've taught them the skills above, now we want to ask them some questions and actually make sure they can get that accomplished without us walking them through. I was trying to think. And then single branch, dual branch, the else with the if with the else, and then finally we added in an activity, and this has a lot of stuff because it has some print statements and how different ways you can print. I'm just going to skip that for now, but all of those are in there. And then the multiple branches down here with an example every time in tech tips. And watch some of the tech tips, because I don't know about you, but Becky and I have both talked about when it gets into a looping section, we try to make sure we put the tech tip in there of how you get out of an infinite loop. So those, you'll see them over and over. Anytime there's a loop involved, I think Becky, all of us, I think that tech tip is listed anytime there's a loop at all in any of this. And then at the end of each of the activities, it actually gives a programming challenge. So write a program using conditional statements and the calculator. And here it is, write a program to compute the average of 3 test scores. Make sure you can choose an appropriate data type. Once the average is written, use a conditional statement to determine whether they earned, what letter grade they received. So the second, I'm not going to go through the next one very much, but I want you to see, if I can make this change, come on. The teacher activity looks exactly the same, except there are answers. And we give a few little teacher notes. Make sure you've taught modulus operator, or if not, now would be a good time to do that. Something like that, just some teacher tips to go through. And in this particular one, all the answers are in red so that you know that's different than what the student had. So that's activity 1, very little, it's just calculator. Many of the things are really just learning the concepts and going from there. Then we go to activities 3 and 4. So this one goes a little bit further, same type of computer science principle standards listed. And then you will see, learn the basic hub commands. So if you've never used the hub before, you can still go in if you have them and do these activities, because we're going to walk directly through them, and put conditional statements with them as we go. And then the turtle. So you can see, start from the very beginning, like input, light, color, and sound, where you get it, what it does, where it's located on the calculator. So everything there is walked through completely. Pictures, where you plug things in, how everything goes together, hoping that this will be something that you can do. So finding the difference in the A and the B into the little connection, so that you, the little USB unit to unit, to make sure you plug the right part in. All of that information is on here.
Beck and I have talked. I'm kind of really excited this year because I don't know about y'all, but if you group your students in groups, this would be something that as you're printing off these, if you print off these activities or you send them to them digitally, students could be working on in groups, and you as a teacher are now going to be freed up to kind of wander around and troubleshoot little questions as they're going, because we've kind of tried to write them so students could be a little self-sufficient with exploration, which makes it so you can spend an extra few minutes getting the student caught up who was gone yesterday, or the student who does get stuck in an infinite loop and they need some help figuring out how to get out of an infinite loop. So they're very much step by step, so students can work in group and do those problem solving pieces with each other, which will free you up a little bit as a teacher to kind of go around and troubleshoot.
Thank you. And so again, with the hub, then we give you some just short answer questions here. I want you to figure out, using this hub activity, here's how you get red, here's how you get blue, or green, how do you get blue, how do you get purple, pink, teal, yellow, those things. And the reason that I wanted them to write these down is they're going to want it again later as you get on with the activity, so that they don't have to go back and experiment again to try to find, now, how did I get pink before? So they have a few choices there. And there was a question, Becky, can you see? I don't know what that said.
So the question just popped out. What if you don't have the materials? Can you use the loan program? What's nice, and I'll show that when Becky passes me the ball, because that way she doesn't have to get out of where she's at. But on that main link that we sent you where the lessons are, right at the very end is the borrow button for borrowing some equipment. And so that information is right in there, just a couple of tabs over from downloading the lessons.
And Becky and I were very lucky in that when Becky and I taught together for many years. I actually taught Becky first, and then she was my student teacher. So she and I, we loved the TI, so we just kept trying to find new things. But even though there were new things that we could afford, we couldn't afford to buy everything. So we have definitely used the loan program at Kelly Welch High School. So
I think we thought outside the box too. So like if it says it needs the Innovator hub, every one of my students, I don't usually give every one of them a hub. I will group my students up into groups of like 3 or 4, because A, if they have music going, that means you have not as many music things going at once. But B, that also means as they're typing their code, somebody else could be using the Innovator hub. And so I think I usually do about a 3-to-1 to a 4-to-1 ratio with either the hub or the Rover. And then that way too, they do some partner programming and everybody's benefiting from the troubleshooting and the problem solving that's going on in the group.
I noticed I put a little note in here. So when you're using tone and note for the sound, one of the things that's kind of, if you go to the TI website, it tells you this exact thing, plays a specific note for a specified time and tells you what the notes are and the octave range. I just put a hint on here. When using the hub for sound, use the numbers 3 through 7. If you get outside that, it starts making kind of an error noise. And you think, what's going on? That's not right. And it just has to do with some of the ability of those sounds on the hub. So I threw that in. That was not, that this is me. So maybe you guys have better luck than I do, but that's what happens.
If you have a hub and you have not played with the hub with your students yet, we played with the hub one day and the next day I had a student bring in our school song, like the sheet music. And he goes, I don't know what we're doing today, but can I code the school song? And I looked at him and I'm like, well, sure, you can code the school song. And so it was cool. About 20 minutes later, here we go. We have the school song going. And it was this great conversation because the kids are like, well, okay, so what if the tuba player brought in the tuba music and the trumpet player brought in the trumpet music because all of their sheet music was a little bit different? They're like, what would it sound like if we had like 6 of them going? So students will really get involved when you start playing with music, especially your more musical kids. And like I said, the sheet music has appeared in my classroom before.
And then you say, well, what does the hub and the Rover have, or the hub have to do with this? Well, the whole idea behind teaching those concepts now, I have a program that I want them to write. And so it's going to, if you can see my window there, just ask them one for yellow, green, blue, purple. Ask them a question, what color do you want? And then they need to write. So I put that up for them. Here's what it's going to look like. But then so that they have a menu, and now they have to actually code the if, then, else if, else in there to get that to happen. And I gave them quite a few little hints here. Input, use the RGB color to set the color, make the RGB, and so it kind of walks them through. So even though this is a challenge, it doesn't tell them how to do that, to perform the task, because they hopefully learned that before, but it says now pause a half a second between each note, pause 2 seconds after you play the entire octave, that type of thing. So it kind of gives them a checklist too. And Becky and I both, we would take something like this and turn it in. If this were a performance assessment for us, that would become actually a rubric for us grading. And we could just go through and check mark then, yes, they've done that, they've done this. And, it makes grading real easy as well. And then finally, this turtle module, if you have not played with the turtle module, if all you have are the calculators or the software for computers, you can go get the turtle module, which is very similar to the turtle module that comes with Python from the Python website. So you can actually do that right here, but you do have to add the turtle module to your calculators beforehand. And I talk about that. I think that's on the teacher page actually for this one. So, and it starts real simple, make the turtle do this, make the turtle do that, etc. And then kind of gave them a little, if you know how to make a for loop, you could actually use a for loop. So it does an introduction to a for loop if they want to draw their square using a for loop instead. And tech tip about the, like what I said earlier about loops and the random module. That's big in Java and on the AP CSP, if I'm not mistaken, that's also big on there. So we went ahead and threw in some of the random so that they're dealing with random numbers. I'm going to hurry through this one, but then a programming challenge, which is kind of crazy. It has a lot to go. And actually, I gave some of the code so that these numbers, the randomly generated number 3, etc., can be drawn up here. And I just said, keep this code, put your code before that. So it's going to draw the picture and then it will actually tell them. And the reason for that is when you have the turtle module, it takes over the screen. So it's not showing you like print statements on the calculator screen anymore, that output screen. It's got its own graphic screen. So you have to print graphics and actually use the graphics commands built into this. So the write command, etc. And so I just put that together because that really didn't go with the if then part. I just wanted them to be able to know, well, it drew a triangle. Did it work right? Well, yes, it generated a 3. So that was what it was supposed to do. I think that's about it on this one. I'm going to try to get, I did not know why all of a sudden my menu down here isn't showing. Sorry. And then, oh my gracious. Sorry. Activities 3 and 4. And for some reason, it will not let me change from activities 3 and 4. I apologize. Becky, you want to talk about something real quick?
Well, I was just going to say, so Underwood, are you going to go do a little turtle graphics real quick?
I am. I was.
So
That's where I'm
question
trying
in
to
the
get
chat
to.
window, whether it's been on the Nspire or
Uh-huh.
not on the Nspire, who has used turtle graphics before with their students, and has there been something kind of cool that you've drawn or done with turtle graphics?
Okay. I finally have my window back.
That's okay. They're thinking about turtle graphics back.
That's
Has
right.
anyone done turtle graphics before?
Are they?
The window's a little quiet.
Uh-oh.
That's okay. We are going to show you. Maybe we haven't used turtle graphics before, so that will be something
Right.
new for people to take a look at. Turtle graphics, as you're going to see, is really nice, slick, and easy. It's what we've done before with turtle graphics, or with my students. Is we've drawn shapes before. Students can draw their name out. They can draw houses. So Beck's going to show you here what a turtle graphic looks like, and we'll all learn something new.
And what's really wonderful about it is if you do have just maybe 3 or 4 rovers, according to the task that you ask, there's definitely tasks that can be done with the rover and can be done with turtle. But if you are making a task with the rover, make all your students do it with the turtle first, so everybody has a method to, a process to go through, and everybody can be working. And then as it's finished, they can go plug into the rover, and there's just a little bit you have to change. So I want to show, so activity 5, I'm not going to go through it too much. It just continues and adds some things. I do turtle with the rover so that you can see, I'm going to make them do some things on the turtle, then make them do the same things on the rover. I wanted to show this last thing that I included. They're just, I call them task cards. And the idea behind this is that you print out some sets, make them, maybe laminate them, cardstock, so that you can keep them from year to year, and you can have your kids just go through them. And I did this one for the conditional and functions. There's task cards on there. So you're done, you've gone through the unit, and now you want to see if the kids can actually perform some task on their own. You can give a different task to each student, and some of them are definitely much simpler than others. Some involve the calculate, and I tried to write calculator only or whatever, but you could give these to kids for them to solve and then rotate the cards. So it's just a method that you could do that. So on here, calculator only, convert to Celsius, Fahrenheit, just something that wasn't in there. This one, Roman numerals, because that makes it easy. If they enter a 1, they have to do a pretty extensive conditional statement to get all that in. Still calculator only. Quadratic formula program. Maybe you have some kids that are maybe a little higher level math. They might do this as opposed to some of the others. So you can really differentiate instruction with these. Calculator only. Another one. Here's one with the hub, just something else. So kind of a performance task at the end. Write a game so that the hub displays a certain light and plays a distinct sound depending on whether the answer is correct or not. And I was trying to get to the one, RGB, random numbers. This one, like, you don't want to choose something like this to have kids do with the turtle. It's not going to work. This one is moving around, and so that's just rover, okay? That one would be rover only. But this one, Okay, write a program that makes the rover trace out a geometric shape based on input from the user. You should allow for at least 3 choices. So this one, you could actually say, you're going to do this on the rover, but I want you to start out on your turtle. And so that's what I want to actually play with right now is the turtle. And Becky, stop me so you have time when it gets going, okay? I'll just do a little bit. We may not finish the whole program. So I started a new document. And if you've not done this, you go down to Python and type new, okay? And give it a name. I'm just going to say web 1 for this is for our webinar. And I'm not going to do anything with this. There are choices. You can bring in different, the different header files for you, but I'm just going to leave it a blank program now. If I choose or not, because it doesn't like me right now. There we go. And so I start with a blank screen. Well, all through that activity, I made them draw some menus and to kind of walk them through the steps. And now I'm not doing anything with Turtle to begin with. So in order, I need my calculator here. So I hit the menu to get to everything, and I'm going to just start with the print statement. And I may not do all of this because we don't have time, but I'm going to put a print statement in. So under built-ins, input, output, print statement. And for now, I'm just going to say in quotes, 1 colon 4, I'm just going to say triangle. So that's the shape I'm going to give them a choice for. And I'll go ahead and put a separate one here. Now, sometimes kids will type rather than using the menus. If I'm on the handheld, I absolutely use menus. If I'm on the calculator, sometimes I type the word print, but quotes 2 colon square. We'll just do those 2 for now, even though I said 3 shapes. Oh, good. Thank you, Becky. She said, notice that the strings turned into the green. And so you can tell with kids what's the difference there. Now, the next thing, I need them to have a variable, which they have had to do. I'm going to call it choice equals. And if you've taught Java, you know we have to get an answer and change it into an integer because that's what I'm going to use in my conditional statement. So, well, you know what? I'm not going to do that. I'm going to get it through the menu. Menu, and I need a type. So I'm going to go get the int. It adds the parentheses for me. And now I need an input statement because I want the user to give me some information. So
for those of you who are new to the graphing calculator with Python, notice all the menus that Becky is clicking on right now are the same pictures that you saw in the documentation.
Yes.
So it's going to walk the students through how to get to those in the menus.
And yes, there's pictures of everything. Okay, so I'm going to say, and whoa, my hand is weird here. I'm just going to say choice for now, just because I don't want to type too much. And I think the document actually said to you do 3 choices, but I'm doing this much. So I'm going to run my program, which Control R will do that, or you can do it through the menu, run, and notice it gives you that shortcut. And it says choice. Now I can type whatever I want because it's not going to do anything yet because I haven't told it, but I wanted you to see that that much is printing. It does allow for me to enter something. Now, because I want that to show up on this particular Python shell, that to show up before it goes to Turtle, I am not going to put my include statements until after that. So right now, I'm going to go in here to menu. Now I had to add this module. So more modules, and it's very simple. There's instructions on the website. If you go to TI website and search for Turtle module, and then it will let you download. And inside there, there's a document that gives you instructions, and it walks you through how to get it on your calculator, how to get it on your computer. Very simple. But once you've done that, then number 6 shows up with Turtle graphics. And so the move function, well, sorry, I don't remember what I was doing. I was talking. Okay, sorry. More
You have
modules.
to import your library before you move.
I have to import it before. but I wanted to import it after I was finished with that other window. If you put this at the top, I may do that just for an example real quick, because I think it's kind of weird. So I put it here. If I run my program, it's waiting on me to type something behind there, but you can't see it. So I wanted you to know what it does. So that's why I choose to just wait. You can do this a variety of ways. This is an easy way, okay? So now that I've done that, based on my choices, 1 and 2, I need a conditional statement, which we've walked them through. Built-ins, I want a control. They should know that by now. And since I only did 2, I'll just do the if else. It's either going to be a triangle or a square. So if, just like you would do in regular old Python, if choice equals 1, we have to make a block. Can you add the turtle module? I missed it.
Keep going, Underwood, you're fine.
Okay. So now what I need to do is, since I said triangle, I need to draw that. So menu, that's with the turtle. So I have to go down here to the turtle graphics. And we've experienced, they will have already looked at these. I want to move forward, let's say 50 units. And then I'm going to turn, and I would normally be asking students, how much am I going to turn? What do I need to do? But I know I need to get moving because Becky's got some great stuff to show you. I'm going to turn right 90 degrees, not 90 degrees. How many degrees for a triangle? Hopefully somebody said that. Okay. And then how many times do I need to do that? So triangle, 3 sides, I would need to do that. And for speed, I'm going to copy paste. Oops. And Becky, talk about why you like the diamond, why I'm getting this one set.
I don't know if you have ever tried to problem solve on Python without the diamonds before, but I have spent, I want to say hours going through students' code that looks 100% workable to me and not have it run. With TI, those little diamonds help you with your indentation. So if you have an if or you have a while, or every single time you need an indentation, those diamonds show up. And I can easily see, oh, this student has diamond at 3, not 2. And actually, my students don't have an issue with their tabs because they can see the diamonds as well. So that, I think, is my favorite part of looking at the Python on the calculator.
I've only taken care of the first one, but I'm going to go ahead and run. So it asks me, I'm going to put in 1 for the triangle, and it's going to draw my triangle. Okay. Now, once it's here and it says finish, you actually have to hit a key to get out of there. And then you go back to the shell that shows you what you did, and then you would click back to this. Just for time's sake, I'm going to stop here. The else, we would draw the box. The biggest thing that I want you to see is under these more modules here. If you're dealing with the move command, pretty much anything, I think anything there, Becky, also works on the Rover. So you could make them, you know, if you have tasks that use any of those commands, and there's a few others as well, but those particular commands, you could make them actually use the turtle first if you only have 2 or 3 rovers. And then when they're finished, it's really kind of cool because all that changes is this T, because the object turtle is the object now. And when you import your rover, it makes a RV, is what the RV would go here where the T is. So you can say, okay, it's working here. Now I'll just make them change to the right header, your right import statements. They could go change this to RV and 50. If I use 50 on the screen, I'm going to put a 5 when I put it in the calculator, because it's the 50 would be moving all the way across your classroom. You would not have space for that. Okay.
What I like about the turtle draw is there's so many things you can do with students right off that gets them moving and gets them, shows their creative side. So my students have written their initials before. We've designed houses before. You can use functions. You cannot use functions. So there's a lot of things you can do with just this visual draw that's usually highly engaging with kids if you give them some voice as to, do they want to have triangular windows or rectangular windows? What color are their windows going to be? What's the roof going to look like? And then if you want to have multiple rectangles, maybe we should have a function that lets you draw a rectangle. So there's a lot of things you can do with that turtle draw that's very visual with students.
Becky, I think I've thrown you the ball so that you can go for now.
All right, so we're going to pretend you're at the end of the course now. And so you have already walked through with students how to do loops. You've already walked through with if statements. They know how to do functions. And you want to see at the end, how do they do with putting everything together? But we still want it to be somewhat scaffolded to give them some support. So we're going to take a look at crack the code real quick. Crack the code. If we take a look at it running real quickly, maybe we're going to run it really quickly. So I have 5 spaces. I know that in those 5 spaces, the sum of the numbers are going to add to 28, and there are 4 odd numbers. So I might type in, well, 1 is an odd number. Let's see where we're at. Oh, goody. I have 1 odd number so far. I need 3 more, and the sum's going to go to 28. All right, let's try a 3. No 3s. Let's try a 5. Woohoo. Okay. So it looks like I might have the total wrong spectrum here of my odd numbers. Oh, there we go. Oh, good, good. Okay. So we know I have 4 odd numbers. They're all showing. The sum is 28. So what do we have on the screen so far? 14, 15, 20. So I must have an 8. Well, it took me 8 guesses, but I could run through and guess my number. If I hit Control Run again, notice it's going to generate a new set. This time I only have 3 odds, and so I would walk through the same steps. So what does the handout look like that we'll give students? So just like the activities that Underwood showed, you're going to have your objectives at the top. It's going to walk through the students and give them an idea of what their final project is going to look like. So there's an original picture, what people have used for guesses, and then the final product. So you could hand this to your students, or you could do a quick demo like I've done to kind of give them an idea of what it looks like and play a few rounds. Just depending on your style. In my classroom, we'll probably play a few rounds, just like maybe on a projector board, and then I'll give them the handout. So this is the end of the course. So step number 1 says you are going to generate random integers between 0 and 9. We saw that on the board. You're going to need to clear the shell as well. So what library imports should you include? So for anybody who's coded on the Nspire before or in Python, what's the library that you need to generate random integers?
Looking to see. Can anybody type that in an answer there? Random.
Random, okay. Well, so let's go see if there is. Oh, I think I'm going to have to break this to get out of it.
Yep.
Yep, okay. So it is the random library. And if you don't know, what I love about the Nspire is there's this menu option. So the students can go down and look and say, oh, there's a random option to get my random integers. And then there was another one that I was going to need. It said, I'm going to have to clear the shell. Okay, well, I either need to know how to clear the shell, or I'm going to have to know which library is it in. Is it in math, random, plot library, pub, Rover? Or is it a time, system, draw, image question? And I'm going to tell you that it's in the system, TI system library. As a teacher, if I have, gone through the whole course and I'm like, I don't even know where they're going with this question, or you want to make sure yourself, if you scroll down, just like Becky said before, the teacher notes right here tell you you're going to need the int library or the random library, and then you're going to need the system library. So any questions that I ask the students, the teacher notes in there are going to tell you the answers. So the next step, they say they're going to write a pseudocode for a function. So for our pseudocode, it says write pseudocode for a function to generate a random list of 5 integers. Each integer is going to be between 0 and 9. Determine and store the number of odd integers the list, as well as the sum of the list. Return the code in the list with 5 integers, the sum, and the number of odd integers. So we're going to do a little front loading with students. So in pseudocode, what are some things that you're going to need to do? And then the next step is going to have them code it. So notice it doesn't tell them the code they need for their function, but we have built in some test code down below so that once they have their function written, if they execute it, they should have 5 randomly generated numbers, the sum, and the number of odds that are there. So what I've done ahead of time, so I wouldn't have to type in front of you all tonight, I typed in exactly what the kids saw on the screen. They have their 2 library inputs, and here's their code for our test code. It said for our function, we're going to have to generate a list of 5 integers. So hopefully by the end of the year, your students are going to be like, well, I need an empty list. So that's step 1. Then they're going to say, I need it to generate 5 integers between 0 and 9. So I need to repeatedly do something. What kind of statement's going to let me repeatedly do something? What do you guys think? I want to repeat something
Anybody
5 times.
in the chat window? 4?
I would pick a 4. You could do a while statement, but then you're going to have to do a counter.
Or
So I'm going to say for I in range of 5 numbers. Well, those numbers are supposed to be generated into my code. So again, this is at the end of the course. So students have probably walked through already the list activities. So they know that they need to append a random number. They might forget, I don't know about you if you know multiple languages, but exactly what's the syntax in Python? It's a random int. It was right there in my menu option. All right, let's go back and check. A random list of 5 integers, determine and store the sum. Oops. So I'm going to need to make a sum variable and maybe start that out at 0. And then I also need to know how many odds there are. And so if I come down here and now say, well, my sum needs to add on, and for those of you new to Python, this plus equals is not how I learned to code at the beginning. So I probably would say the sum plus the last number entered into my list. But my students are like, Byron, that's just so much typing. Can we please just do a plus equal? So my students will probably do that.
And
then
Becky, can you talk about though on the AP computer science test? Will they see both?
put me on the spot.
sorry.
I don't 100% know that off the top of my head. I know my students have
Okay.
seen both. And so
Okay.
for me, it hasn't been a thing I've had to specifically go back over.
Okay.
And then last but not least, if it's odd, okay, if you have not seen an if statement on the Python emulator, it's kind of cool because if I go into my built-ins and I go to ifs, and actually I think Underwood, you might have done this. I wasn't paying attention to see if you
Yes.
did it from there or not. Here's my
I did.
template that tells the students, there we go, whether or not it, something's going to go there. So I'm going to say if that last number that went into my list is an odd number. Beck talked about modulus today. That's going to be in one of those early if statements that she was doing with controls. If it is odd, I'm going to take my odds and increase by 1. All right, so there's my code. I'm on purpose going to make a mistake. You feel free to throw in the chat what my mistake is, but I'm going to go ahead and run it while my mistake is there. When I run it, it tells me I have an invalid syntax. Oh, well, that was not the mistake I was meaning. I should have an S, so I have multiple S's there. All right, I still have an error. What am I missing on my function? If I look at the way we're going to use our function down below, what am I missing? Anybody know? I'll return. Yep, I need to return in order my code, the list I just created, my sum, and then my students need to know I called it num odds here, and then I'm going to catch it down below as odds. Now if I run it, I still have a syntax error.
It's
and
on
that's
the return, babe.
Well, I was going to say, because if you look at my diamonds, I had 3. So again, notice it's going to give me some errors when I have issues. Oh, one more semicolon. Okay, I really had more issues than I thought. There we go. So I was able to generate a random list of 5. We could double check and add that up real quick to make sure it's 26. And I only see 2 odd numbers. If I run it again, I get a brand new set like so. One more thing. So I was hoping that this would show up. Let's say I forgot to put the equal sign. Notice that my number of odds feature isn't working. And so the reason we have this test code down in below is to help students pick up some of those little minor errors as well. And so as I'm looking at my time here, we're not going to 100% be able to walk through everything else that's going on this project, but I just kind of want to show you the layout of the activity here. So it says it's end of the course. So remember, students have gone through lists, they've gone through ifs, they've gone through selections. So once this section of code is working, it's going to prompt them the next part that says, now write the code for the check statement, because you're going to check to see if what they entered is in the secret code list. And now it's going to have them code it. So again, I don't give the students the code here because they're going to do that. We ask them to type their new code down here, but now there's a new set of tests down below to let them test the code to make sure they're on their right handout. On the right track. And again, if I'm the teacher edition, I'm going to tell you this is only my 2nd year of teaching Python. I've taught coding languages forever, but Python is still newer for me. So it's kind of nice, I don't know about you all, but having the answers at the back end just to kind of check and to realize that some of these are going to be a little different. So like in the teacher handout, here's that sum plus equals, but other people might have went ahead and put sum equals sum plus code minus 1. As you know, your students might have stored this as a number so they wouldn't have to access the back end. If you're new to Python coding, for C++ and Java, you're not allowed to have a negative index number there. And so, oh, well, thank you. Like I said, 2 years, it was a crash course 2 years ago on Python. Negative indexes before, C++ and Java don't allow that. And so what I've learned as I've taught Python versus C++ and Java, there is a lot of things that Python will do that other coding languages don't do. And so I like the fact that we've coded back at the back end. For those of you who are new, because it sounds like in the chat window we have some new people in the audience. Python does something I never would have expected. Let's make a variable A and a variable B. Beck knows where this is going, and a variable C. If A equals B equals C, let's print true. Otherwise, let's print false. All right. The question is, and I might have already given it away, does this work in Python? And for those of you used to a different language, does this work in other languages? Well, let's hit run. That says false. Well, if I change the first one to a 5, A and B are now equal, but C is not. It's still false when I run it. And now if I put this to a 5 and I run it, it says true. The first time my students turned a project in that looked like so, and they had multiple comparisons, because I have a question that has you enter in 3 side lengths, and I'll tell you if it's a right triangle, if it's an isosceles triangle, if it's an equilateral triangle. I accidentally docked a student because I said there's no way that's correct, and the kid called me back over to their desk and they're like, look, it runs. And I was like, oh, that really does work. You can actually do even more comparisons. This will compare all day long. And what's even more interesting, for those of you who haven't done Python before, is you can assign, I want A, B, and C to be declared in one line. This kind of made my head hurt a little bit. But when I run it, why do I have an invalid syntax, Underwood? Do you see anything?
I do not.
That should work. So that's great. It's not working.
It should work.
But it also, I'm not sure why it's not working. But you can put more than one variable on the left and have it catch the values you want on the right-hand side. And it's, oh, good catch. The 2 equals down below. I got rid of my D,
Oh,
but
you got
not
an
my 2
extra.
equals.
Yes.
There you go. So
Thank you.
so that was false. I can put 2 5s back there, and now it's true. So Python has some interesting oddities your first or second or third time through. So don't feel bad if you start doing something in Python and those of you are used to a different language and you're like, that is not what I expected. It's okay. We've all been there.
And
So
be careful if you teach multiple AP CSP and then you teach AP computer science, because that won't be okay on the AP computer science because it's not legal in Java. So you just kind of have to keep your mind with what you're doing. So.
All right, with that, I have passed the ball back to Stacy.
Awesome. Thanks, ladies, so much. It was amazing. A lot of information. I think everybody that was on is going to have to go back and rewatch because we all need to brush up on our Python, but then also all of these computer science resources are amazing. For you guys that are attending at home, I did put into the chat the link to the document as well as a certificate of attendance for tonight. If you were watching on demand, you can paste that into your favorite browser. Like I mentioned earlier, in a couple of days, you will get an email with a link to the recording as well as all the associated documents. Please feel free to check out the website with all of the different resources that these ladies presented. So thank you, Becky.
Wait, don't we have a drawing going on, Stacy?
Oh, yeah, you're right.
Oh,
You're right.
drawing.
Look at you.
Nobody logged off yet. There's a drawing, though.
So the lucky winner for some TI-Nspire technology is John Shemp. So John, someone from TI will be contacting you within the next couple of days and getting the information. Thank you so much, Becky. I almost forgot.
Congratulations, John.
Yes, exactly.
Yes, yay.
So thank you all at home for joining us. And if you were watching on demand, thank you for joining. And we'll see you next time. Bye-bye.
Bye.